it builds up a lot of debris because you get a lot of dust, a lot of rust, and things like that. And if you don't move it, it gets caked in there and it doesn't move, and you can't move it. Then you force it, then you end up breaking parts, which we have a lot of in the back there if you need them. And so if we do that at least once, twice a week, you'll keep everything lubed up and ready to go. Okay. So on the left head here, you just see we got a hood, and this is very important too. You got when you're going through, you got the rollers and you got the chip breaker. So if the chip breaker and the feed rollers come down and this side pressure goes in, if these are not set correctly, then sometimes your board wants to move inside the machine. So when it moves inside the machine, it goes through here, and then the left head, say it's out just a little bit, you don't have the correct pressure on it. When the board comes through, that head wants to do like this. The board's moving, not the head. The head is stationary to the machine. But if you don't have pressure as you need it, the board wants to move, so when it passes through and it comes out the back, you'll see imperfection in the profile you're trying to get out of it. So we always want to make sure this is also lined up. So when you put your cutter head on, make sure your pressure shoe, your chip breaker, and all your wheels is lined up with the diameter of your cutting circle of your cutter head. And when you do that, then the pressure will be set exactly where it needs to be, holds that wood towards the fence. These top rollers are made to a point, they've got what they call teeth on them, and they're very aggressive. If you look, it pulls the wood towards the fence. If you got the feed rollers backwards, it'll pull the wood away from the fence. And a lot of times people don't realize, and some people I've seen down the road will actually take, just like this one here has got a mark. So if you have a lot of turnover in your plant and a lot of people and they get in a hurry, maybe mark the outside of the roller so you know exactly which side faces you to make that wheel work properly in production. And a lot of times people don't want to put a little Sharpie mark on it. Well, that's all well and fine. I'm getting old, don't remember well either. And something like that will determine, so, oh, I got to do this to make this thing work, because if you put them on backwards, it will fail you every time. So just little things like that kind of help you, go through the day. So then we move on back through here. We also have a fence on the left head, and it's got to be parallel to the cutting circle, which is the diameter of the head. So you set that in line with that, because if this fence going through, as you're cutting your wood, as you're going through there, as you're cutting your wood, that is set right, the pressure and stuff is set right, the left head's set right, but then the fence is in too much. So once this left head cuts it and releases it, if that fence protrudes out away from the cutting circle, it's going to hit, and when it hits, it's going to stop the product. Okay, and then people are going to say, uh-oh, what's wrong? And again, you're going to hit the down button on the feed beam to try to put more pressure to force something through the machine that's not going to go, because you've got resistance here. So make sure this is set correctly. If you don't, you're going to get it every time. Sometimes, you go in there and you set it just a little bit loose. I'd rather have it loose than a wood way too tight. So try to remember, loose sometimes a little bit better than way tight. And then when you go through here to the top head, we have chip breakers. And you see we have counters on the machine. And those counters has a purpose. So when we measure our tooling, we get a diameter, which is a number. From the center point of the spindle to the deepest part of the knife would be the minimum. And from the center point of the spindle to the largest part of the knife would be a maximum. So when we do that, we measure these, and these numbers do act very, they're important, because now you don't have to take a straight edge, get inside there, do it like the old ways. If I know a number is 2867, so I crank it to 2867, up here maybe 2865, so on. Then once I run my board, it's going to come out correct. If you don't use a number system, you're doing like this, it's try and error, and that takes up time and wastes a lot of wood that you'll never get back as well. So when we move on through the machine here, as you see, these rollers, if you want to run something small in diameter, you must take those off. You can actually put a 3/4 inch wheel on there and run down to, like a 1 inch piece or whatever, especially if you're doing like quarter round and things of that nature. So, and you see we got air pressure on there to make sure you ain't got a lot of air pressure. If you see up here, we're about 3.5 bars with 2 bars and 2 bars. So don't go down here and crank it all the way up to like 6 bars, because it's over pressure anything and everything, and then it eventually wears your wheels out, wear your pendulum shafts out, wear your bearings out, and all that stuff. So again, too much pressure is not always the right answer. So as we move through the top head, you see we got a chip breaker, and that chip breaker actually holds the wood down while the knife comes in and cuts the wood, so it doesn't break it all to pieces. That's why I call it a chip breaker. So we'll make sure the chip breaker is set pretty close to the cutting circle, so you don't want that head too far away from the chip breaker, because once that head comes in there at 6,000 RPMs, it's ripping that chip out of there. You got something holding it down, and it actually breaks that chip very nicely and doesn't leave a lot of debris that you have to clean up later. Thank goodness on this one we have two top heads, so the other head will clean it off if you got enough to do so. But inside here, it's what you call a receding chip breaker. It kind of goes up. Get a board. It kind of goes up and away, if you can see. See how the board goes up and away from the cutting circle. So we want to set that fairly close, because as it runs, when the board comes in and put pressure on it, it's going to go up and it's going to go away from the cutting circle. But inside here, there's a mechanism built up with some springs and some tensioning rods. So after a period of time, that builds up with a lot of sawdust inside here. Inside this hood, you really can't see it. But down in here, you got these bolts. And again, when you've got some downtime, you can take that pressure shoe and the chip breaker off, blow all the sawdust out of it, clean it up real good, and put you some of this like hydraulic oil on the surface of these two pieces, and it moves up and down quite good. When you're using a lot of different types of oils and stuff like that, it becomes sticky and gooey. You don't want to use like that. You want to use something like an oil base that you can do, and not a lot of grease, because it attracts a lot of dust and it gets impacted, so you don't want to do those things. So clean that out, because what happens is that'll get impacted with sawdust and all kinds of debris. Then you're running a wood, and then that pressure or that chip breaker does not want to move freely. So then when it happens, it gets underneath there, and then normally, see, it's moving pretty freely. So when the board gets in there, it's got resistance, and it has to move, because when you're going in, you're going heavy, then the cutter head cuts a little off and you become light. So when you're putting a lot of that pressure underneath there, it's got resistance. And then if you run something really oversized, you got more resistance, and then it does not want to feed. It gets about right here, and it want to stop on you. It doesn't want to go any further because there's resistance. Well, don't go and push the feed beam down, because that's not going to help you. Don't get back there with a sledgehammer and start beating the daylights out of it, or get your buddy on a forklift backing into the board to try to get it to drive through, because when you do that, you're going to have to, your pendulum shafts with bearings and stuff, you're going to have major issues. And of course, your boss probably wouldn't want to see you on a forklift beating wood through the motor. And that's back in the old days, we used to call them stickers, because they were stickers. You run a board through there and they get stuck all the time, because nobody really could get it set right, because we didn't have the technology we do today. But thank goodness we do, so you should be able to achieve what you set out to do. So again, clean this, make sure it's clean, everything's good. And also over here, we've got this what they call floating pressure shoe. It's not a real big, heavy-duty pressure shoe, because this is the first top. It doesn't do a whole lot. It actually holds and maintains the wood till it passes through. Then right over here is the driving machine. This is the second top, and we're very fortunate to have two tops, because years ago we came out with 5 heads, and it's hard to do a lot of profiling and stuff like that with 5 heads. But now you can do a double profile. You can put a knife in here if you're doing big crowns, casings, bar rails, stuff of that nature. We can put 2 sets of knives here, 2 knives there, 2 knives there, and pre-cut and finish cut. You're not taking all that material out at one time, and you get a beautiful Weinig finish. That's why Weinigs are the Weinigs, because back in the day, when you run Weinig, you didn't have to sand anything, because everything was perfect, everything was beautiful. And it still are today if you maintain and run your machine properly. So as we go back here to the main function of the head, or the motor, we got a second top. As you see, we also still have a chip breaker, and it's also the same as this one. So if it gets built up, things of that nature, it's going to put resistance, and it's not going to feed. And this is more important so than that one, because if this one doesn't feed, it's going to sit there. This is your finishing knife. That's your finishing. So once all the products are running through there, this is going to leave that beautiful Weinig finish that we're so proud of. That is going to sit there and varnish and burn that wood and leave that. So eventually when you come out through here, you've got to cut about a foot of it off because it's burnt and just close the grain so bad that you can't use the wood. And we don't want to lose wood because wood is very expensive, trees are hard to find. So therefore, maintain your chip breaker, your pressure shoe, make sure your cutter heads are really good and nice, and they're on there where they need to be, and you'll get good results at the end of the day. Also, we got a driven table roller in here. Will help you in between the two heads, to help you drive that wood out. If you see, the center point of that roller is about the center of the shaft. So you've got perfect hold down between this roller and that roller. It acts like this and it drives it through there. Where back in the old days, you know, you had rollers, but we didn't have a lot of activity in the bed to help you drive it. And those also got to be set and maintained. You see, they're not above the table, just barely. All you want to do is when the wood comes across it, it's spring loaded to have just enough spring tension on it to actually help hold that wood and pull it through. Not a lot of lifting, just hold and pull, okay? So that's all that does. Then we go back here in the back, on the pressure shoe back here, this is also kind of a beast. And if you look inside, I don't know if you can get a good shot of that or not, but if you look in here, the pressure shoe comes from the factory, kind of like this. It's kind of like a little roll. What we normally do, we take the pressure shoe off and actually bevel it. Because if you look at the board, when it goes through a machine, it's pretty much square. And when it goes through there, it hits that pressure shoe. And most likely when it hits it, it knocks it because you got 4 bolts in the back that actually holds that pressure shoe on. So when the board hits that pressure shoe, it knocks it down this way, knocks it over this way, or even that way. So then what happens, the board gets stuck in there. You got some bubble back there beating the board. What it does, it stretches the bolt back there, and that pressure shoe comes more down and actually holds the board, restricts it, it doesn't feed. Then eventually you got to open the machine, clean it out, and then you run another board without fixing the pressure shoe. You're going to have the same problem repeat over and over and over. So when something like that does get stuck, please take a minute and kind of look and see what's going on with it. So if you see that board is stuck against the pressure shoe, know that there is something maybe going on, that the pressure shoe is out of parallel now, and don't try to rerun a board, and don't try to bring the pressure shoe up, because when you do that, then the board's going to get through there and it's going to get loose and you're going to get sniped and get bite off on it, because that pressure shoe has a wonderful purpose to actually hold the wood down while the cutter head is cutting it, and it feeds through to actually eliminate any kind of imperfection in the wood, which we call snipe or bite off. So in the back there you got 4 bolts. So normally what we do is go back here and loosen those 4 bolts. So what we do, we'll crank that head down, and you got a shim under here, so go off of here. Take the shim out of this plate here, bring them 2 table plates together, and we'll get a 2 4/8 spacer. So you'd have 1 spacer, so we'd have 2 spacers like this, and if you measured them, so there would be like a 2 4/8 spacer. You would have 2, then you would put 1 here and 1 back here. Then you would loosen all 4 bolts, and you would bring the pressure shoe down parallel to these 2 spacers. Then what would happen, you got 4 bolts in the back, so you got 2, the 2 top ones. If you tighten the 2 top ones, that pressure shoe would go like this. If you tighten the 2 bottom ones, it would kind of go like this. So it has a purpose on how you tighten and how you align the pressure shoe. So take those, put them underneath there, loosen that, bring it down. So now let's just assume that the pressure shoe is leaning inward. It's leaning towards the outside of the molder, but that wood hits it, knocks it down, so it's leaning. So what we want to do is loosen that, and what that does, it frees that up. You go in the back and you got the 2 bolts in the top. So you tighten one of the top bolts, and that should bring that corner up. So then you take your spacer, you go underneath there, and you go back and forth on the front where the damage was done, and then that way you determine how close you are to getting it back parallel. then while you're doing that, with the space around this table, you're also doing back here too. So when you do that, you may have put resistance on the back part of this, so you may have to go back on the bottom left-hand corner and tighten the corner bolt up, which brings that back up, which brings that down. So all those bolts does have a purpose. So you continue to play with that, and when you get it where you want it, you lock it down, left to right, top to bottom. You don't go two tops, tighten them down, two bottoms, tighten them down. You determine the one you work with first, which would be probably the first top right. You tighten it down. Then you go the bottom left, tighten it down, and then repeat the whole sequence again. Then your pressure shoe should be back parallel once again. And also during the maintenance time, if you got time, this thing here also builds up a lot of debris and trash and stuff like that, moving it back and forth. And also if you live in a high humidity state, it sometimes can accumulate rust. So take this thing off. All you gotta do is loosen that up, break that nut loose, break that off, clean all that up in there, and then put you some really nice lightweight oil on there and lubricate that up really, really nice to maintain that so it moves freely back and forth. Because if you don't, eventually it's going to get to a point it doesn't move and you get stuck and things of that nature. So try to keep it as clean as possible, try to maintain it as much as possible, and you'll get good results at the end of the day. And also these counters, you see we got counters up here for the top head. Now also in regards of the cutting circle, so back in the day where we didn't have that, you take a board, take a sample, and you put it underneath that cutter head and you try to adjust it to get it close. Well, right now with a measuring stand, with an OCMS stand, things like that, we have the equipment that you need to maintain these cutter heads to a point. And as they get dull, you're going to get resistance, you're going to get a bad finish. So make sure your knives are always sharp and ready to go, regardless of what you're doing. Okay, so we move on back here to the last table. This table here, it's got a 20 thousandths shim under it, and reason being is because it takes only 20 thousandths off, and that's a finishing head. So regardless of what you're taking off on the molder, this head is always going to take 20 thousandths off, and that leaves that premium finish, that no sanding, beautiful wood finish on the Weinig that we always, you know, brag about. And also we've got a driven roller in the back there, which helps drives that wood through the machine. If you'll look, they're pretty much center too. So it's like a pinching effect, which that top roller comes down, the bottom roller comes up, pinches that wood, and both of them drives that wood out. If this thing gets out of whack, gets out of parallel, it's below the table, doesn't put pressure on it, and the feeding kind of comes more and more resistant. It doesn't want to feed as well. And then again, you might think there's something wrong with the end feed up here, and it's really just this roller here is not putting enough pressure on the bottom to bring it out of the machine. And also if this thing's extremely tight, then when you release that board into this wheel, this kind of puts down a lot of pressure. It's also spring loaded, so don't put a lot of pressure on it. You want it to move freely underneath there, and that's what hangs up the machine, and wood don't want to run through there and things of that nature. Okay? So, questions on that? So we're going to walk around the back a little bit, and I'm going to show you a little bit on that. I know we're kind of hitting the highlights, but the good thing about this, with this video that we're going to do, not to say that, you know, you can watch it, and when you watch it, if you got questions and things of that nature, you can also chime into it, and we'll take time and we'll sit down and we'll answer the questions. Or if you want to call me or something like that to ask, you know, specific questions stuff, I'm glad to take your phone calls and do whatever needs to be done to help you through this process as well, because that's what we're here to do, is to help you through this right here. So if you look back here in the back, this is all cart and drive. It's all got gearboxes, and it's gear reduction. So what makes it great is you don't have any chains or any sprockets that actually have any kind of imperfections. So when you're running the molder and you're running the wood through it, you don't have chains and sprockets that actually stretch. You go like this, you know, you get imperfection in the wood. This is all perfect sequence together, cart and drive. So once you turn the feet on, all of it's moving simultaneously the same throughout the machine. So it works perfectly. And Weinig designed that years and years ago. And that's why a lot of people don't realize the importance of research, because we've work through these problems and try to find solutions that people has in the woodworking industry. That's why Weinig is 100 years old. That's why we're still here today and try to service and maintain our customers the best we know how. So with saying that, you have dry shafts actually goes through here. And they also have bearings. As we talked earlier in the front of the machine, when the wood's coming through the machine, you got resistance, it doesn't want to feed, then you try to put pressure on the rollers, then those bearings up front takes a lot of that stress. And when you take another board and you whack it and you try to beat it through there, you're putting a lot of more stress on these universal shafts and also your bearings inside. So every time a board goes through there and you put pressure down on it and it's more resistance, these has to work harder and they're cogged. So then you got your cogs, they could stretch, your bearings could pop out, all kinds of things could happen. So you don't want to overwork and overexert your machine during this time. So just try to make sure everything's properly aligned up and ready to go. So if you look down here, we've got what you call those spider gears. They're made out of rubber. So what happens is when you turn the feet on, they don't go like this. They all start up the same, and sometimes when you're going through the machine, after a period of time, you go through and you see little imperfections in the wood. So sometimes down through the years, these could start wearing. So this roller here could do a little bit more funky things than the front rollers, and you'll see that in the wood. So always come back here and make sure, you know, these are properly seated and set. And if they look like they got wear on them, you know, you call us and give us your E number on your machine, and we'll find out the part and we'll send you these and you replace them. You got a set screw here. All you got to do is loosen that, pull these back, put your new ones in, push it back in, lock it, and set your set screw. They're not hard at all to replace. So it's fairly simple. So on your cardan drive, that's pretty much the maintenance. And you got oil in here, and you know, you look at the sight glass, make sure they're all full. If you see one leaking and things like that. Another good thing about here, if you see something and it is leaking or whatever, you can call us. We've pretty much got those on the shelf ready to go. If not, we also have a wonderful man in the back named Josh. He has a bench repair, and you can send those parts to us, and we can replace them, rebuild them, and send them back to you in a timely fashion. So we can also rebuild a lot of things that's on this machine here in the bench repair in the back. And we also have like another place in the back called rebuild. So if you got machines and you want something done to it, you can send it here. We can refurbish it for you. We can replace the spindles, replace the motors, whatever here in our facility versus us coming to your facility. If it's something simple, we got technicians, and yes, it's April Fool's Day, but again, they're still out working. If you need us, all you gotta do is call us, and we'll send somebody to your facility and help you out in this time that you need. Okay, so we went through the cardan drive, we went through the feed system. So we start back here in the belts. You see the belts is a pulley. Weinig has come up with this many years ago because this is not a direct drive. It's a motor and a pulley, and you got a belt that separates the two. So back in the day, we used to have what you call a banjo mount. The motor hung off the spindles, and a lot of our competition still uses that concept today, and that's why we got away from it, because if you got a motor hanging on your spindle, that big old heavy motor is putting weight on the spindle, so you get a lot of imperfections in that spindle, and you put a lot of weight on it, and it's wanting to do this. So when it does that, guess what? You got a cutter head on the end of that spindle. So when that motor is not wound right and you got imperfections in the motor, it transfers into the spindle, and the spindle dumps it into the wood. Then you don't have perfect, beautiful wood that you want to you know, kind of sell to your customer. So what we have a motor which is mounted to a casting. We've got a spindle that actually goes through a quill, and it's separate, and the belt drives the spindle separately. So that way any kind of imperfection in the motor is transferred into the belt and not to the spindle, so you have good quality cut at the end of the day. And also in these wheels, if you look, we've got central lube here, and I'll go over that in the back and show you there too when we get done. But you got two tubes coming in here. You got a front and a back, a front and a rear. So from central lube system now, you can actually grease the front of the machine, and the grease comes back through a line into these zerks and actually greases your quill. So back in the old days, you had two zerks here and here, and you had to open all the doors, get back in there, and grease each and every one of those. And a lot of times it was hard to find them because they was all over the place. So if you look now, you'll see lines, and those lines goes to grease search. And the good thing about it is keep the sawdust out of the machine. Try to blow it out at least once a day, because if you've got a line leaking, the evidence would be grease on the floor. So then something's not getting greased, so then that way you can find the line that's broke and try to fix it. That way you get grease to whatever cert that's not getting it, and the parts won't be broke. So make sure the lines are in. Also in the quills, you've got 2 cut slots there. And what we do is actually kind of pack that, clean it, pack it with good grease. And as you see, it gets a lot of buildup up on it. Take that off, clean it up real good, and repack it with grease, because what happens there too, when you fire the machine up, the spindle rotates and rotates at 6,000 RPMs, and it gets kind of warm, and it uses that grease as a lubricant. So it gets down into the quill, onto the spindle, so when you're trying to do axial adjustments this way and that way, it allows that spindle to move freely and not get jammed up. Where back in the old days, we had a crack kind of this way, and it filled up a lot of dust, and then when you tried to move the spindle, you'd actually break the gearbox, you'd break an adjusting rod or something of that nature. So now we've kind of figured out, okay, that was a problem, so we kind of fixed it by putting grease certs on here that you can grease from the front, and also putting these little slots in there so it can kind of get the grease into it directly. And same way here on the top, the spindle, and you see it's belt driven. You also got zerts. You also got a crack in there too. I shouldn't say a crack, but you got a crevice that actually fills up with grease and acts the same thing. When the heat builds up on the spindle, it kind of melts the grease and uses it as a lubricant. And as it gets dirty and nasty, replace it, put new back in it, and you're good to go. And also down here on the bottom, you'll see these bolts on the motors. And what we do is loosen those motor bolts, and then the way the motor kind of like pushes down, you also should have a little tool that goes in this hole that's cut out, and you take a wrench and you push, and that motor goes down, which tensions your belts. And you'll see the sound and hear the sound. You just want just a little bit of play in it. You don't want it too loose, you don't want it too tight, because what happens is if the belt becomes too loose, then you fire up the motor, and you're trying to run the wood, then it bogs down. It sounds like we don't have enough power. And what happens is the motor's speeding up, but the spindle is slowing down, and the wood's getting in there and getting jammed up because you don't have enough belt tensioning to drive that spindle to the full capacity to cut that wood like it should be. And that's sometimes the problem. People call up here and say, well, no, it sounds like it's bogging down. I think I got a bad motor. And come to find out, it's just a belt loose on the pulley. So make sure the belts are always maintained, things of that nature too. So we went through the belt, through there. So if you go back through here, we have limit switches. So sometimes people try to run bigger stuff than they should, or smaller stuff than they should, and it doesn't go in position. Well, again, maintenance is something really important. A lot of times big companies, they put the doors on here and they run and run and run and run, and this thing builds up with a bunch of sawdust. So when it builds a bunch of sawdust, there's 2 things could happen. You have a fire hazard for one thing, and also all your parts that's moving in there is bound up with sawdust. And these limit switches sometimes the victim of all that, because it builds up, it gets in here, it gets in the crevices of these 2 castings, and eventually when you're trying to move it up and down, these wheels, these rotor wheels on that will actually eventually break, and then you try to bring something up and down and it doesn't work. And on the machines with a computer, you get a fault, or this one here, you're trying to crank it up, and it don't want to do nothing. So most likely it's something like this, and you see we have a stop here for this one. So when it goes up, we know that's high enough, because if you look at the distance on the casting, it's on dovetail slides. So once you do there, you're at capacity as far as the thickness. Because if you go any further, it goes up and it could fall off the casting. So that's why we put that there, for your protection, and also protect the machine from harm. Okay? So we come on back through here. We see the air cylinders. All the air cylinders, if you look over here, we got that. Once you put it in position, that kind of locks everything, the feed beam, in place. And sometimes people say, well, my feed beam won't go up and down. It won't go up and down. It doesn't work. Well, come over and look and make sure this cylinder is attached, and make sure the air line's not leaking, and this rod's working. So when you go to engage the feed beam, you'll see this actually engage or disengage to allow it to move either direction you want it to go. If that doesn't work, then more likely this thing right here is bad. But not to say that you're down and out. If it does go bad, you need to be up and running. You can also override that manually by just taking your wrench, reach in there, and actually loosen that up, do what you want to do, and then tighten it back up when you get in position. So it's not a, oh my goodness, I'm down forever. We can get through these things. We can get by these things. We're overcomers. We can achieve great things with working together with one another. Okay? And also, the funny thing is, and the biggest laugh that I get sometimes, especially if you're living up in the north, people call me, and you know, I'm down here in the south, I talk hillbilly. They call me and say, I got a problem with my machine. I say, well, what's wrong with it? And they go, well, it ain't running right. This ain't this and that. I go, okay, where do you live? Well, I live in Pittsburgh, Pennsylvania. Okay, what's wrong with it? Well, I run it, and it gets jammed up. And I've checked everything. I said, okay, have you checked the levelness of it? Oh, you crazy. But what happens is, say, if you do have a building, and in the wintertime, and the machine, if you look at the feet, and it's over a crack in your building. So in the wintertime, the water runs around your building and absorbs into the dirt and pushes up on the concrete. Then it actually will come in here and get your machine unlevel. So when the summertime comes, the thaw comes, and actually recedes, and then the ground changes, and the concrete settles back out, machine's unlevel. So when you're trying to run the wood, these machines are made by Weinig. They're very precise. They're like a jeweler making a beautiful watch. I mean, they're very precise. So the least little imperfection in levelness will actually affect the way it runs. So always go back, get you a good machine that's level, go back, you know, within the seasons, make sure everything's good and level, because if it's not, you go back here and you re-level the machine, and the problems you're having most times will actually fix yourself just by leveling the machine. And sometimes that's the biggest call we get, machine's not running right. Well, it's summertime, it's stalled out, have you leveled it yet? No, I haven't leveled it. Well, sometimes it takes, especially if you're up on a mountain at a lumber mill and it's been a real bad winter, you want to level your machine. So we can do that. We'll walk around here and show you the central loop real quick. So right on here, as you see, which we call a central loop system. All the lines are in the back and underneath are lines going from this place into the back there. And as you grease your machine, it's going through a line, going to each grease zert. And again, that's why it's so important to make sure your machine is cleaned out, the sawdust and the debris is gone, because if you're greasing this thing, the machine and the line has popped or broke, and you don't see the grease, well, it's not getting greased, and you go to move something, it's tight, it won't move, more likely you're going to break a adjustment spindle or a locking device or something like that. So if we maintain it and keep it clean and make sure the grease is getting where it needs to go, then we'll have good results at the end of the day. If you don't, then somebody's going to have to end up buying parts, and we got a bunch of them in the back. We'd love to sell them to you all day long. So this right here is what we call the central loop system. It's centrally located for all the grease zerts of the machines. So it's very simple, and we'll show you. And another problem we've been having is, if you look at this grease gun, this grease gun should come with any and all machines we sell. If you look at it, it's got a backfeed tube. So when we put this grease gun on the zerts and we're pumping the grease into the zerts, what happens once the line fills up, the pressure builds up, and it'll actually feed that grease back into the canister here and won't over grease the lines, and it won't bust the lines. Once it builds up pressure, it releases pressure back into it, goes into the canister, and retains it. Where this right here, for years, is what we call a hydro gun. So if you have a hydro mat, which has hydro heads that you pump up with grease, or we use this on the grinding arbors and also the grinding wheels on our grinders. This is not the gun you want to use for your central loop system, because we can go up to, you know, almost 600 bars on this thing. So when you're actually putting pressure on it, you're pumping, you're going to pop the lines like crazy, because it will over pressurize it You won't know that you popped the lines because you don't have a way to see unless you've got everything cleaned in it. So there's two different guns. So if you have a machine and you pick this gun up and you're going to go and do your maintenance on it, think twice. This is not the gun you want. And also a number three grease actually goes to your high pressure, and a number 2, which is a central loop system, and all your other greasing, that goes into this maintenance gun. So make sure number 2 is a general greasing. Number 3 is like the high pressure gun and all your hydro heads, things of that nature there. So we also have this, which is called servo lock. That takes the place of this. So as we all know, this is a knuckle buster. So when you put that on a spindle and you try to break it loose, sometimes it's very hard. And hope you have a friend, because if you have a friend, one can get one side, one get the other side, and eventually get this bad boy off. If you don't have a friend, then good luck with that. This right here is a new innovative tool that they've designed that you kind of put on here.
Hang on, do that again.
Okay. That you put on here, and you actually lock it. And it unlocks. And that way you're not doing this anymore. So this is a new innovative tool that they came out with, which is really, really nice. And we sell those back there in the warehouse through the tooling department or the parts department, either one. So if you want to buy you one of those, just call us and let us know. We'd be glad to sell you one of those. And always, getting towards the end, always be prepared. Safety first. Make sure you got the proper safety equipment when you're working on it. Make sure when you're doing the maintenance, make sure you lock it out so nobody can get hurt. Turn it off, lock it out, and keep the key in your pocket. Don't let your buddy have it. And that way everybody can go home to their families at the end of the day. And again, we hope this kind of helps you. And again, we hope that if you've got any questions or any concerns, you'll call us and let us know. And also remember, during these trying times, we're not going to leave you. We're not going to forsake you. We're still here for you. And if you do need a technician, we're still open. We get somebody to you. And if you want demos, we're doing actually some live video demos now. So if you want to do a demo, Christian, my buddy over here running the camera, can actually do a live demo and send it to you. That way, if you're interested in a machine, you can see a machine run, you get a hold of your salesperson, maybe inquire a price and things of special needs of some, special tooling or whatever you need. So we're still open for business. We're here for you, and we're going to support you as long as we can. And we hope you enjoy your day.
Someone's asking, what's the machine model?
This is a 218. It's a replacement of a Profi mat. So if you have a Profi mat, this is the replace of that, or a Unimat Gold.
Okay, cool. All right.
Good. Well, thank you all again. Have a wonderful and blessed day.